Okay, I have section 12.4, and this deals with simplifying rational expressions. Now, rational expressions is an expression that can be written as a ratio with the denominator not equal to 0. So, when you're trying to simplify these, not only are you simplifying them, but you also have to look for the excluded values. And excluded values are numbers that you would substitute in for the variable that would make the expression undefined. Basically, what that means is whatever's in the denominator, what value of like x or y or whatever variable that you may be, what could you not put in there to make it 0? Or what could you put in there to make it 0 so to make it undefined? So first portion of this section is we want to find the excluded values, if there's any. So I want to look at A. So all we really have to pay attention to when we're asking to find the excluded values is all we have to do is pay attention to the denominator. So if I look at the denominator, my denominator is 4x, and I got to see what will make 4x equal to 0. And the only thing that will make 4x equal 0 is if x equals 0. So the excluded value would be x cannot equal 0. Anything else? It is a valid um, expression. So again, look at B. All I'm paying attention to is the denominator. And I need to find what 3x minus 9 equals 0. So if I add 9 to both sides, it leaves me with 3x equals 9. Divide that by 3, my x equals 3. So the only way that x equals 0, or the only way that the denominator equals 0 is if x equals 3. So the excluded value would be x cannot equal 3. And for C, I have x squared minus 16 equals 0. And if I add 16 to both sides, it gives me x squared equals, equals, let me erase that. Equals 16. And if I were to take the square root of these values, my x would equal plus or minus 4. So my x cannot equal 4 or negative 4. Now let's look at D. D here has x squared plus 4x plus 5. So I have to see if x squared plus 4x plus 5 equals 0 at all. If I try to factor this, let's see here if I can factor it. So it's here to be x, it would be x, be plus and plus. Now, is there any values that sum is 4, but the product is 5? I can't think of any. So this does not come out to be a perfect factor. But if you look at it, you see you have this 5 right here. So it'll it appears that there's no whole number that would make it negative 5. So I'm going to say that x can be all real numbers. There is no excluded value for D. So now we can go into simplifying radical expressions. And here's a little example that can help you out to help it with the problem. So it's like, if you look at A times C divided by B times C, you can rewrite this as it is shown in the box. And if you have two values in the numerator and denominator and they're through multiplication, you can cancel those out because all they will be is equal to 1, and anything multiplied by 1 will be whatever it is. If it's A times 1, it would be A, and if it was B times 1, it would be B. Just like in this example here, we have 2x plus 4 divided by 3x plus 6. You can distribute a 2 out of both of those, which gives you 2 times the quantity x plus 2. And then the denominator, you can take out a 3, which is 3 times quantity x plus 2. And if you see you have x plus 2 and x plus 2 both in the numerator and denominator, and they're attached by multiplication, you can cancel these out and leaves you with just 2 over 3. Okay? So here, for these examples, they want us to simplify, plus they want to find the excluded values. So first off, I'm going to simplify. So the numerator, there really wasn't anything to distribute, but I can distribute a 6x out of both of them, which leaves me with x plus 5. Because if I distribute that 6x out here, it would bring me back to the original expression. And since I got 6x in the numerator, 6x in the denominator, those would cancel and leave me with 1 divided by x plus 5. Now, the second portion of it is they want you to find the excluded values. So I'm going to go back to the original equation. And I need to find where 6x squared plus 30x equals 0. Again, we can factor out that 6x, which gives you x plus 5 equals 0. And if we use the zero product property, we know that x would have to equal 0 and x would have to equal negative 5. So for A, the answer would be, the simplified expression would be 1 divided by x plus 5, and the excluded values means that x could not equal 0 and x could not equal a negative 5. Okay, let's look at B. So to simplify this, I look at the numerator. I can factor out a 8b, which leaves me with b plus 2 divided by 32b. So I got a b and a b, so those cancel. And 8 32nds can be reduced. So if you divided both sides by 8, this will give you a 1, and 32 divided by 8 would be 4. So this would equal b plus 2 all over 4. And the excluded value, we go back to the original expression, 32b equals 0. The only way that works is if b equals 0. So b cannot equal 0. For example, b. And A, to simplify this, it already looks simplified. So that's the answer as a simplified. So all I have to do is find the excluded values. So 8 minus 1 equals 0. That means A would have to equal 1. So A cannot equal 1 for that particular expression. Okay. We got a few more examples. So looking at D, looking at it simplified, I think I can factor these. So let's parentheses, parentheses. I got x and x. The subtraction sign next to the 12 means it's going to be a different sign, so it's plus and minus. And I think it's 4 and 3 divided by parentheses, parentheses, x, x. The plus sign on the 6 means they're going to be the same sign. The minus sign here means they're both going to be subtraction. And 2 and 3 would be the values that it would be reverse FOILed. And so I have an x minus 3 in the numerator and x minus 3 in the denominator, so those cancel. So that leaves me with x plus 4 over x minus 2. So that's a simplified. To get the excluded values, I go back to the denominator, so I see I had x minus 2 times x minus 3, and I'm going to set that equal to 0. So then all we're doing is using the 0 product property to show that x would have to equal 2 and x would have to equal 3. So our excluded values means that x could not equal 2 and x could not equal 3 for this expression to hold true. Okay, let's look at E. So if I were to FOIL this out, let's see what I got. For the numerator, I got x. The plus means they're going to be the same, plus and plus. And I would say it's 2 and 1 divided by parentheses, parentheses, x, got plus, and 8 and 2, because the sum of 8 and 2 is 10, product of 8 times 2 is 16. I got 2x in the numerator, 2x in the denominator. Those cancel, so my simplified of this expression would be x plus 1 divided by x plus 8. And if I go back to my denominator to find my excluded values, set that equal to 0, which means that by using the 0 product property, my x would have to equal 8, and x would have to equal negative 2. So that means that those values have to be excluded, so those values could not equal x for this expression. Okay. Last example. At x squared minus 7x plus 10. So on the top, I can write it, factor it out as x. The plus 10 means they're going to be the same sign. The minus 10 means they're going to be both negative. And it would be, what, 5 and 2. And on the bottom, I can rewrite this as 5 minus x and 5 plus x. And so looking at it right now, there doesn't seem to be any values I can cancel at the moment. But let's take a closer look at this 5 minus x. I can rewrite this as negative x minus 5. So all I'm doing is I'm just distributing out the negative value and making the x positive, and then making my positive 5 negative. So if I rewrite this x minus 5 times x minus 2, that's what it is on the top, divided by negative x minus 5 times quantity 5 plus x. Now I have an x minus 5 in the numerator and x minus 5 in the denominator. Now those can cancel. So then my value here would be, or my simplified expression would be x minus 2 divided by 5 plus x. And looking at my, get some more room. Whoops. Now if I look at my denominator here, I'll go back to my original one where I had 5 minus x times 5 plus x equaling 0, this means that x could not equal 5 and x could not equal negative 5 for this particular expression. And that is simplifying radical expressions. Hope this helps. Until next time.